Question 11. This question is from topic calculus. Here in this question, we have a curve whose equation is y equals to x times sine x. This curve passes through the point at P whose coordinate is pi by 2, pi by 2, and the curve also passes through the point Q whose coordinate is pi 0. And we have a straight line which is the normal to the curve at point P. Now, for the first part of this question, we have to show that the normal that passes through the point P does also pass through the point Q. So, let's begin. Let's write the equation first. The equation is y equals to x times sine x. Now, let's differentiate this equation with respect to x from the both sides. So, it's d over dx of y and d over dx of x times sine x. Here in the right hand side, the x times sine x is a product of two terms. So, let's see the product rule of differentiation. If we have two terms, uv, so d over dx of uv would be, here u and v both are functions of x. So, it would be u times d over dx of v plus v times d over dx of u. So, we are going, let's use this formula here. So, in the left hand side, let's write dy over dx, on the right hand side x times d over dx of sine x plus sine x times d over dx of x. So, the next line we can write dy over dx equals to x times cos x, because derivative of sine x is cos x, and plus sine x times 1, because derivative of x is 1. So, now at point P, x equals to pi by 2. So, using x equals to pi by 2 in the equation of dy over dx, we get dy over dx equals to pi by 2 times cos pi by 2 plus sine pi by 2. So, cos pi by 2 is 0 and sine pi by 2 is 1. So, dy over dx is 1. So, we can say the gradient of the tangent at P is 1. Therefore, a gradient of the normal at P is minus 1. Let's see why. If a line has gradient m1 and another line perpendicular to this line has gradient m2, then product of m1 and m2 will be negative 1. So, the relationship between the gradients of tangent and normal is negative reciprocal. Now, let's try to find the equation of the normal. So, equation of the normal will be, let's think about a rule. If we know that a line passes through a point x1, y1 and has a gradient m, then the equation of that line can be written as y minus y1 equals to m times x minus x1. So, using this rule, we can find the equation of the normal. We can write y minus pi by 2 equals to minus 1 times x minus pi by 2. So, this is the equation of the normal. Now, we need to show that the point Q lies on this line. Coordinate of the Q is pi 0. So, if we use x equals to pi and get y equals to 0, we can say that Q lies on this line. So let's use x equals to pi, on this line. So we get y minus pi by 2 equals to minus 1 times pi minus pi by 2. So in the next line we can write minus pi by 2 plus pi by 2, which gives us 0. So we can say that the point Q lies on the normal at point P. The normal that passes through the point, P. So first part of the question is done. Let's move on to the next part of this question. Now for the second part of this question, it is given that the derivative of x times cos x is cos x minus x times sin x. With the help of this information, we have to find the integration of x times sin x. We cannot use the integration by parts rule as it is not part of the O-level syllabus. So let's assume that our x cos x is dx, x cos x is z. So let's write x cos x equals to z. So we can write dz over dx equals to cos x minus x times sin x. Now let's multiply the dx with the entire equation. We can write dz equals to cos x times dx minus x times sin x times dx. Now let's rearrange this equation so that x sin x dx becomes the subject of this equation. So x times sin x dx equals to cos x times dx minus dz. So now let's integrate the entire equation. So on the right hand side, so in the next line, not in the right hand side, so in the next line we can write x times sin x dx equals to integration of cos x dx is sin x. So let's write sin x, then integration of dz is z, so we can write minus z plus the integral constant c. But z is x times cos x, so let's use this. So we can write integration of x times sin x dx equals to sin x minus x times cos x plus c. So this is the integration of x times sin x dx. The second part of our question is done. Let's move on to the third part of this question. Now for the final part of this question, we have to find the area of the shaded region. Let's write the coordinates of P and Q in the figure. Our P was pi by 2, pi by 2, and coordinate of Q was pi, 0. Let's draw a perpendicular line from P to line OQ, and let's call this line PM. The coordinate of the M will be pi by 2, 0. Now if we integrate the equation y equals to x times sin x from x equals to pi by 2 to x equals to pi, we will get the area under the curve from x equals to pi by 2 to x equals to pi. But this area will also include the area of triangle PMQ, which is not shaded. But if you subtract the area of the PMQ, then we will get our desired area of the shaded region. So we can write area of the shaded region equals to area under the curve minus the area of the triangle PM. Now let's try to find the area under the curve from x equals to pi by 2 to x equals to pi. So let's write area under the curve, let's call this area A1. So write A1 will be the integration from x equals to pi by 2 to x equals to pi, and it will be the integration of x times sine x dx, But from the second part of this question, we know that the integration of x times sine x is sine x minus x cos x. So let's write A1 equals to sine x minus x times cos x. Let's put the limits here, pi by 2, and here pi. So let's use those values in the next line. So we can write A1 equals to sine, first we will use the pi, so sine pi minus pi times cos pi. We use the upper limit, now let's use the lower limit, minus sine pi by 2 minus pi by 2 times cos pi by 2. So A1 will be, if we use the calculator, we will get the value of the A1 as 0 minus pi times minus 1 and minus 1 minus 0. So our A1 is pi minus 1. So this is the area under the curve from x equals to pi by 2 to x equals to pi. Now we have to find the area of the triangle PMQ. So let's draw a line. Okay, so let's write the area of the triangle. The area of the triangle PMQ is half times MQ times PM. This is half into base into height. We use that formula. So length of MQ is pi minus pi by 2. Length of MQ will be pi minus pi by 2, that is pi by 2. So it's equal to, let's write pi by 2. Okay, now we need to find the length of PM. So our PM, the length of PM will be pi by 2 minus 0, that is also pi by 2. So using those values, we can write the area of the triangle PMQ, we call this A2, is half times pi by 2 times pi by 2. That gives us pi squared by 8. So the area of the shaded region. So the area of the shaded region is pi by 1 minus pi squared, pi minus 1, it will be, I said wrong, pi minus 1 minus pi squared by 8. Let's use the calculator. Using the calculator, we get the value is 0.91 units squared. So area of the shaded region is 0.91 units squared. So this question has been solved completely.